Good morning, ladies and gentlemen. Welcome to the video on effective interest. Now, before going into actual effective interest, we need to make a quick note on compounding periods as assumed by the BCE. So, first one is fairly easy. 12 months in every year. Makes sense. 4 quarters in every year. 26 fortnights in every year, even though there are slightly more than this. 52 weeks in every year, even though there are slightly more than that. 365 days in a year, ignore the existence of leap years. If you go on and do finance in uni, they make that 365.25, which is frustrating. But for right now, have those. They're pretty self-explanatory. All right, and we'll never compound by the minute or by the second or continuously, even though that does happen in real life. All right, so the nominal interest rate is the interest rate you see advertised in banks. It is the quoted interest rate. What we're looking at today is what's called the effective interest rate. The effective interest rate is the percentage by which a loan or deposit increases each year. We use the effective rate essentially to compare financial options. It's related to the comparison rate. The comparison rate includes all fees and charges, and for some reason in BC we don't actually look at comparison rates. We just look at effective rates. Now that sounds a little odd. How can something grow by a different amount if it's, well, each year? So this is an illustrative example. Pretend you want to borrow $100 for a year and you have 3 banks to choose from. Bank A is 4% compounding annually. Bank B is 4% compounding quarterly. Bank C is 4% compounding monthly. Now note, these interest rates are the ones being quoted and they are the nominal rates. So they're the ones that are being told to you. And looking at them, you might think, well, at the end of the year, I'm going to have to pay back $104 because each of them is 4%. It doesn't actually work out that way. So let's have a quick look at this. So 1% compounding annually is quite easy. So $100 compounding annually is fairly straightforward. You have $100 to start with. Over the course of the year, it just increases by 4%. So to increase it by 4%, we multiply it by 1.04, and at the end of the year, there is indeed $104. Fine. So here we would say the effective rate is equal to 4%, because that's the amount it's increased by. Let's look at what happens quarterly. Now, quarterly means that every quarter, the amount in the bank has interest earned or charged on it. So in this case, we're being charged interest, which means interest is being charged every quarter. It's not 4% each quarter, it's 4% over the year. And because it's 4% over the year cut up into 4 quarters, is effectively 1% per quarter. So here, the rate per quarter is equal to 4 divided by 4, so 1%. Now, there's a couple of different ways we can do this, but let's think about it as a recursion relationship. The amount the loan is valued at initially is $100, and then what happens is to get to the next quarter, we take the previous quarter and multiply it by 1.01. That there has the effect of increasing it by 1%. And then we do this 4 times. So, if in your calculator you can put in, well, 100, then you can go through the table or through run mode. I'll show you one way. So in run mode, because this is quite an easy one, we're starting off with $100. Put in 100, easy enough. Then we do the answer multiplied by 1.01. At the end of the first month, we now owe $101. At the end of the second month, we've been charged interest again, but now it's slightly more, and more, and more. So that at the end of the year, we are having to pay back $104.06. Doesn't sound like the end of the world. So that's what we actually owe. So V4 is equal to $104.06. This means the effective rate, remember the effective rate is the amount we've actually increased by in the year. The effective rate is 4.06%. Okay. So note that even though we started with a 4% nominal rate, and the 4% nominal rate is here, the effective rate is in fact higher than the 4%. All right. Now you might guess what will happen with monthly, but let's play it out. So the rate per month is equal to, well, the 4% divided by the number of months in a year, because that's how often the interest will be charged. So 4 is, well, 1/3%. Now 1/3% is 0.33333%. So to increase this by 1/3%, once again we're starting off with $100. And to get to the next one, we take the previous one and increase it by 1.003333. I would write several threes in there, unless you're going to go exactly. I'll do this quickly on the calculator, and bearing in mind that we want to do this for 12 periods. Now 12 is quite easy to lose track of, so let's use a table this time. Start with 100. That's initially, and now remember, in the cell we're about to enter in now will be the value at the end of the first month. Equals A1 times 1.003333333333. That's month 1, and we want to go down a little. Doesn't matter if we go too far, because what we're going to look at is number 13. $104.07.4. That's the amount we need to repay at the end of the year. So the value at 12 is going to be $104.07.4, which means the effective rate is 4.07, we'll round it to 3 significant figures, %. Now note, that was originally 4% monthly. Effectively, what that does is that actually increases the value of the loan or the deposit by 4.7%. That's the difference between a nominal rate and effective rate. The effective is the amount it actually jumps by each year. The nominal rate is the amount quoted. Now, some notes on how we can compare these quickly in sort of multiple choice style questions. In general, the higher the nominal rate of interest leads to a higher effective rate of interest. Ceteris paribus. It's Latin, meaning holds all else equal. It's one of those economics terms, doesn't pop up in maths that often. In fact, what it means is that if we hold, say, the compounding periods equal, so we have a 12-month compounding period and a 12-month compounding period, this has 5% interest, this one has 6. The one with 6 as a nominal interest rate will have a higher effective interest than the one with 5. So the ceteris paribus, holding the compounding periods equal, the higher nominal rate will have a higher effective interest rate. More frequent compounding periods leads to a higher effective interest rate, ceteris paribus, or set par. That can be seen up above here, where we had this, the same nominal rate, so that was kept equal. The higher the compounding rate, and the higher the number of compounds, the higher the effective interest rate, as we can see by the 4 effective rates there. Now you might be thinking, that seems like a really long way to go about it, having to do a recursion equation each time, a recursion relation each time. Good news is, there's a better option. There's an equation. Bad news is, it's terrible. That's the equation there. It's worth having in your book. It may come up in multiple choice. I've actually never seen it come up before, but it's in the course. So to calculate the effective rate, you have to put into the formula 1 plus R, which is the nominal rate, over N, which is the number of compounding periods in a year, over 100, multiplied, close bracket, to the power of N minus 1 times 100 to get into a percentage. The way you're more likely to do it is to use the CAS. So using the CAS, you go to run mode, and then go menu, finance, interest conversion. That's annoying. Menu, finance, interest conversion, effective rate. We want to find the effective rate. We'll just type in EFF. Then the first number you put in is the nominal rate, so nominal rate of 4, then comma, the number of compounding periods in a year. Compounding monthly, we saw that it was 4.7. EFF, 4% compounding every quarter. There's our 4.06. Neat, huh? So, effective rate is illustrated there, and then you've got 2 ways to calculate it. Largely, you're going to use your calculator, clearly. Alright, hopefully you've got that down comfortably. Thank you very much for watching.